Today we will cover section 6.6, which is on solving radical equations. We will go over how to solve and check all types and explain how extraneous roots occur. To get us started, let's take a look at an example problem. This is an example of a radical equation. A radical equation is an equation that contains radicals, and within the radicands, there are variables. Remember that a radicand is the number under the radical symbol. The first step we have to do is raise both sides of the equation to the same power so the radical can eliminate. If we take the square root of both sides of the equation, then the radical on the left side will no longer be there. We will end up with 4x plus 12 equals 36. We are then left with a linear equation, so all we have to do is solve. So we are going to subtract 12 from both sides, and we will end up with 4x equals 24. And from here we divide, and we get x equals 6. Our last step is to make sure the solution checks back into the original equation. To do this, all we need to do is plug in 6 to the equation. So we have radical 4 times 6 plus 12 equals 6. We end up with radical 24 plus 12 equals 6. We get radical 36 equals 6. And this, in fact, is 6 equals 6. 6 is the solution because when we plug it back in, it satisfies the original equation. Let us try another problem. So we have negative 6 plus radical x minus 3 equals 2. Now, this radical equation is a little different because there's a term outside the radical. Our first step is to isolate the radical on the left-hand side of the equation. And to do this, all we need to do is add by 6. So we get 6 minus 6 plus radical x minus 3 equals 2 plus 6. We end up with radical x minus 3 equals 8. Now we can solve the rest of the equation like we did in the previous example. First, we square both sides to eliminate the radical. And we end up with x minus 3 equals 64. We now have a regular linear equation, so we just have to solve like we normally would. We will add 3 to both sides, and we get x equals 67. Lastly, we check the solution by plugging in 67 back into the original equation. So check 67. Negative 6 plus radical 67 minus 3 equals 2. Negative 6 plus radical 64 equals 2. We get negative 6 plus 8 equals 2. And this, in fact, is true. So 67 does satisfy the original equation. So now that we have completed a couple of problems, we understand the steps needed in order to solve radical equations. Remember, isolate the radical so it is the single term on one side of the equation. This will be your first step. Second, raise both sides to the same power so you can eliminate the radical and then end up with an equation. And this equation could be linear, quadratic, or other polynomial equations. Then you will just solve the equation like you normally would. And lastly, check all possible solutions. So now let us take a look at more complicated examples and apply the steps we just learned. So we have the fourth root of 3 minus 8x squared equals 2x. The radical is already isolated, so our first step is to raise both sides to the power of 4. I'm going to raise both sides to the power of 4. And I will end up with 3 minus 8x squared equals 16x to the 4th. We're going to move the 16x to the 4th to the other side of the equation so we could solve. So we get 3 minus 8x squared minus 16x to the 4th equals 0. And you might want to rearrange that so you can notice that it is factorable. 3 minus 8x minus. I'm sorry, my mistake. It is easier if we move 3 minus 8x squared to the other side so we won't have to deal with a leading negative term. So 0 equals 16x to the 4th plus 8x squared minus 3. And we notice that this can factor. And it will become 0 equals 4x squared minus 1, close parentheses, open parentheses, 4x squared plus 3, close parentheses. And then from here, we may even notice that 4x squared minus 1 is a difference of 2 squares. So we can simplify that further into 2x plus 1, 2x minus 1, and the 4x squared plus 3 stays there. Now we have to solve each resulting equation. So we get 2x equals negative 1, x equals negative 1/2. We get 2x equals 1, x equals 1/2. And we have 4x squared equals negative 3. X squared equals negative 3/4. X equals plus or minus square root of negative 3/4. And this is imaginary. because we cannot take the square root of a negative number. So we don't have to worry about that. But we do have to check the other two back into the original equation. First, let us check negative 1/2. We get fourth root of 3 minus 8, parentheses, negative 1/2 squared equals 2, parentheses, negative 1/2. And we just solve 1/4 equals negative 1. And we get the fourth root of 1 equals negative 1. And this is not true. When the solution does not satisfy the original equation, it is called a extraneous root. This is a very important thing to know. Remember, an extraneous root is when the solution does not satisfy the original equation. So, negative 1/2 is in fact an extraneous root. Now, let us check 1/2. We get the fourth root of 3 minus 8 times 1/2 squared equals 2 times 1/2. We get 3 minus 8 is 1/4 equals 1. 3 minus 2 equals 1, and we get the fourth root of 1 equals 1. And this is true. So 1/2 does satisfy the original equation. We will continue the rest of the lesson in the next video.